The mystery of light. Why it acts like both a wave and a particle. Have you ever wondered what light really is? You see it every day, streaming through windows, dancing on the surface of water, illuminating your room, guiding you through darkness. Light is so familiar, so essential, that we often take it for granted. Yet, when scientists began asking the simple question, what is light? They stumbled into one of the greatest mysteries in the history of science, a paradox so strange, so profound, that it changed the way we understand reality itself. Because light, as it turns out, behaves both like a wave and like a particle. And this dual nature defies everything we once believed about the nature of matter and energy. To understand this mystery, let's journey back to the 17th and 18th centuries, when two great minds clashed over the true nature of light. Isaac Newton believed light was made of tiny particles, or corpuscles. Meanwhile, Christian Huygens argued that light was a wave, spreading through space like ripples on a pond. For decades, the debate raged. Then, in the 1800s, Thomas Young conducted the now famous double-slit experiment, in which he shone light through two narrow slits and observed the resulting pattern on a screen. If light were a stream of particles, it would form two distinct bands. But instead, the light created an interference pattern, ripples of brightness and darkness, just like waves do. This was powerful evidence that light behaves like a wave. However, this wasn't the end of the story. In the early 1900s, Albert Einstein confronted another mystery: the photoelectric effect. When light was shone onto a metal surface, electrons were ejected, but only if the light had a high enough frequency. What's more, increasing the intensity of low-frequency light didn't help. It made no sense if light was just a wave. But if light was made of tiny packets of energy, which Einstein called photons, then everything clicked into place. Each photon carried a fixed amount of energy, and only those with enough punch could knock electrons free. This discovery not only proved that light also behaves like a particle, but it helped launch quantum physics, one of the most transformative scientific revolutions of the 20th century. So which is it? Is light a wave or a particle? The surprising answer is, it's both and neither in the classical sense. Light does not fit neatly into our everyday categories. It exists in a quantum realm where the boundaries between concepts like wave and particle start to blur. This is what we call wave-particle duality. It means that in some situations, light behaves like a continuous wave, while in others, it behaves like discrete particles. But most incredibly, it's not that light switches between these forms, depending on how we look at it. It's that our method of observation determines what we see. This phenomenon is at the heart of quantum mechanics and has deep implications not just for physics, but for our understanding of reality itself. Wave-particle duality isn't limited to light either. Matter, like electrons, also displays this duality. In fact, experiments have shown that even large molecules can exhibit wave-like interference under the right conditions. This suggests that wave-particle duality is a fundamental property of the universe, deeply embedded in the way everything exists. And yet, it challenges our most basic intuitions. How can something be in two states at once? How can a single photon interfere with itself? The answer lies not in the objects themselves, but in the strange probabilistic rules of quantum physics, rules that defy logic but are confirmed again and again by experiment. But why does this matter? Why should we care that light behaves in this paradoxical way? Because this duality is what makes technologies like lasers, solar panels, LEDs, fiber optics, and even quantum computers possible. Understanding how light behaves allows us to manipulate it, to harness its energy, transmit information, and peer deep into the structure of atoms and galaxies alike. More than that, studying light's dual nature reveals the universe's complexity and elegance. It reminds us that nature doesn't always conform to our expectations. Sometimes the truth is more beautiful and more mysterious than anything we can imagine. As we continue to explore this mystery, we find that wave-particle duality is not a flaw in our understanding. It is a doorway into a world where certainty gives way to possibility, where observation itself becomes part of the system, and where the universe invites us to question everything. Light, in its strange dual identity, becomes a symbol, not just of physical illumination, but of intellectual and spiritual awakening. It shines not only through the windows of our homes, but through the walls of our ignorance. It teaches us that reality is richer than appearances, and that the deeper we look, the more wonder we find. So the next time you see a beam of sunlight, or turn on a lamp, or watch the stars twinkle in the night sky, remember, what you're seeing is more than just brightness. You are witnessing the echoes of a cosmic mystery, a paradox that has puzzled, inspired, and enlightened generations of scientists and thinkers. Light is not just a wave. It's not just a particle. It's a bridge between worlds, a messenger from the quantum frontier, and a reminder that even the most ordinary things can carry the most extraordinary truths.